Hi everyone, it's Math with AUB. Let's go it along another frame based on the questions of second year. Second year selection is always good one. I try my best to select some wonderful questions, elegant questions. Question number 1 reads as f of x is e raised x exponential function minus 1 divided by e raised x plus 1. Check whether it is even or odd or neither. We have given a function. We have given the function f of x is equal to e raised x minus 1 over e raised x plus 1. Check whether it is even or odd. For the condition for even, replace x by minus x and there is no change. That is the definition of even function. If replace x by minus x, then the symbol of the complete function changes. That is the definition of odd. That is the definition of odd. Let's check straight away. Replace x by minus x, f raised minus x, f of minus x, e raised negative x minus 1, e raised negative x plus 1. Okay, to change the exponent to positive, write e raised x in denominator as 1 over e raised positive x minus 1 over 1 over e raised positive x plus 1. Taking LCM, in that case LCM is e raised x 1 minus e raised x. What about denominator? Same, e raised x 1 plus e raised x, e raised x cancel. What we have? F of minus x is equal to 1 minus e raised x over 1 plus e power x. To me, if you take minus common at crucial juncture, then you are a man of mathematics, otherwise a child. Taking minus common, it will become e raised x minus 1 over e raised x plus 1. Now you can easily check. There it is overall positive function, now it is negative. So f raised of minus x minus, instead of this, it is value of f of x, and that is the condition for odd function. So the given function is odd. So option number B is the right option in that case. Moving to question number 2. Limit x tends to infinity, x square plus x plus 1 divided by over 3x square plus 2x plus 1. Evaluate at when limit x tends to infinity. When x tends to infinity. Let me read this first. Oh God. Yes. Limit x tends to infinity, x square plus x plus 1 divided by 3x square plus 2x plus 1. There are 4 possibilities to deal limit positive infinity or negative infinity. How to deal this? Case number 1, when numerator and denominator have equal powers, greater powers are equal. What is the greater power of the numerator? X square. What about denominator? It is also x square. When both numerator and denominator have same degree, numerator's degree is equal to denominator's degree. Then how to handle this? Then the coefficient of the highest power, that's our answer. Coefficient of the highest power. Let's see how. Open this up. What is the highest power? X square is the highest power. Taking x square common from the numerator, taking common means dividing by x square. X over x square plus 1 over x square over, taking x square common from denominator, we have 3x square divided by x square plus 2x over x square plus 1 over x square. Cancelled out. They also cancelled out. What remains? Write down limit x tends to infinity. It will become 1 over x, 1 raised x square over 3, 2 over x plus 1 over x square. In case of limit infinity, 1 over x, 1 over x square, 1 over x square, 2 over x square, they are tantamount to equal, they are tantamount to 0. As the quantity increases, in that case, in all these cases, 1 over x, limit x tends to infinity, the denominator increases 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 10, whatever the case is. If denominator increases, then the limit infinity is 0. 0, 0, 0, 0. So we have 1 over 3 is our answer. 1 over 3 is our answer. Case number 1, when both numerator and denominator have same degree, might be 2, might be 3, might be 4, might whatever the case is, but they have the highest degree same, 2, 2, 3, 3, 4, 4, then answer is the coefficient of the highest degree, the coefficient of the highest x, then the coefficient of x square, coefficient of the highest power is your answer. Then there are 3 more possibilities in case of infinity. Let me shed some light on them as well. Beside this question, we have attempted this question, 1 over 3 is the answer. What about other 2 to 3 cases? Let's see and find out. Case number 2, case number 3, limit x tends to infinity, x square plus bx plus c over cx cube plus dx plus ef. In that case, in case of limit x tends to infinity, positive or negative, if the degree of denominator is greater than the degree of numerator, degree of denominator is greater than degree of numerator, then it is equal to 0. It is equal to 0. Then in that case, denominator increases rapidly. Denominator increases in long range. If the coefficient, if the power of x denominator is greater than numerator, the degree of denominator is greater than numerator, then answer is your 0. If not, if that is the case, if the degree of numerator is greater than denominator, say suppose 3x square plus 2x plus 1, in that case, degree of numerator is greater than degree of denominator. In that case, infinity is the answer. If limit x is positive infinity, it goes towards positive infinity. It keeps on increasing, that's the answer. If there is limit x tends negative infinity, then negative infinity is the answer. It keeps on decreasing, it keeps on increasing towards, it is extending towards left. If limit is a negative infinity, if positive infinity, it extends towards positive values. In case of negative, it is negative. Simply, if the degree of denominator is greater than numerator, if the degree of denominator is greater than numerator, then your answer is 0. If degree of numerator is greater than denominator, if the degree of numerator is greater than denominator, then infinity is the answer. The fourth is, if you are going to have overall power x, then these might be the cases of E formula. Then these are the cases of E formula. E formula, you are familiar. 1 plus 1 over x is equal to e raised x. Overall power x in case of infinity might be, it is sure case of e raised something exponential. If degree of numerator is less than denominator, degree of numerator is less than denominator, 0 is the answer. If degree of numerator is greater than denominator, if degree of numerator is greater than denominator, then it is infinity. And in that case, if degree of both numerator and denominator same, then the coefficient of the highest power is the answer. Then the coefficient of the highest power is answer. So 1 over 3 is the answer in that case. Moving towards next question. Find the eccentricity of the given ellipse having center not at origin, 4x square plus y square minus 8x plus 4y minus 8 is equal to 0. Find its eccentricity. We are familiar. Eccentricity of ellipse is always less than 1. Eccentricity of ellipse is always less than 1. Let's see and find out. Let me write equation for you. Ellipse 4x square plus y square minus 8x plus 4y minus 8 is equal to 0. There is no need to transform this into standard form. or might be that is the case. There is no need, just the greater one, it is, what are the coefficient of x square y square? The greater one is a square, the smaller one is b square. Simple guess, educated guess, knowing the fact that if we can transform this one into standard form, then 4 will be in the denominator of y square and 1 will be in the denominator of x square. Knowing this fact, but we are on safe side. We are on safe side to take direct values. Greater one, it is value of a square, it is less than 1, b square is equal to 1. We are not deciding which transverse axis is x axis. No. Transverse axis no doubt along y axis in that case. Sorry, major axis along y axis in that case. Major axis along y axis and minor axis along x axis. If you transform this equation into this form or in this form, but we are on safe side to take a square is equal to 4, b square is equal to 1, then a is equal to and b is equal to 1. Eccentricity of ellipse is given by c over a, where c is equal to a square minus b square over a. So we have a square means 4, b square means 1, over a means 2. Root 3 over 2 is our answer. So it is clearly less than 1. Square root of 3 is 1.732 divided by 2. The denominator is greater than numerator. Denominator is greater than numerator, so percentage is less than 1. Look, we are on safe side. We are on safe side. 4 is going to be the value of a square and 1 is going to be the value of b square. Knowing the fact, if we transform this equation into this or this form, then we might have 4 will be in the denominator of y square over 4 square or x square over 1. Might be there something. Let me give you idea about this as well. You are going to have such type of equation. Look at this x. It is going to be taking 4 common. We have x minus 2x, y square plus 4y taking constant there. It is going to be x minus 1 whole square and y plus 2 whole square is equal to 8. 4 1 the 4, it will become plus 4 and I have plus 4 as well, or whatever the case is. So if you transform this in standard form, 4 will be there, 1 will be there. Knowing this fact, I know this fact, but it is safe to take x square coefficient. This 4 is going to be the value of a square, 1 is going to be the value of b square. We are in a position to direct find eccentricity without indulging ourselves to transform this equation into standard form or in the cases of selection of major or minor axis. We are on safe side. That's our a square value, that's our b square value, and we are in a position to find eccentricity of the ellipse. So E is equal to under root 3 over 2 is the answer in that case. Another good question, 2x cube times e raised x square dx. Integrate. What do we have? 2x cube ex square dx. Everybody deliver the speech. I let rule, inverse, logarithm, algebraic, trigonometric, exponential, and so on. The nutshell of all this is take the first one whose derivative decreases or diminishes. My hint to you is that I can be replaceable by the fact that take the first one whose derivative decreases or diminishes completely. Decreases or diminishes. Look at this. If we take first one e raised x square into 2x, e raised x square into 2x and so on, it will remain constant and keeps on increasing. Take this first one, but with the beauty. Let's see how. If I write x square times ex square into 2x dx, that's our first, it is our second. Integration of this one is e raised x square. Integration of this one is e raised x square. How? Let's see and find out. E raised x square times 2x dx. It's our function, it's our derivative. E raised f of x and it's f dash of x dx, so its integration is e raised f of x, so e raised x square. So this one is mine first, it's our first and it's our second. First same, right, first same x square, integration of second, I have done this for you, it's e raised x square minus whole into first same integration of second, first same integration of second, first same integration of second by parts, first same integration of second minus whole integral derivative of first, it's 2x, integration of second same, e raised x square dx. Look at this, this is still same situation, e raised x square times 2x dx, it is our function, it is our derivative. So let me write in a good fashion for you to give you good idea, e raised x square 2x dx, it's our function, it's our derivative. So e x square times e x square, it is same that we have already done, e raised x square plus c, that's our function, that's our derivative, there is no need to apply by parts, its function, its derivative, simple case is this. Taking e raised x square common, we have x square minus 1 plus c, and it's our answer in that case, by parts. Highlight rule, no doubt, it's something really very special, inverse, logarithm, algebraic, exponential. Let me give you a good tip, take the first one whose derivative decreases or diminishes, take the first one whose derivative decreases or diminishes. Here there is x square, differentiation of x square is 2x, we need 2x, x square into 2x, here remains x square. So that is our first one, that's our second one, and get along. Okay, moving towards next question. Find equation of the tangent to circle at the point 3, 1. There is a equation, not center at origin, because it contains the term x power 1 as well as y power 1. Either of them is present, then center is not at origin. In that case, both x power 1 and y power 1 are present. So it is not a simple case. Find equation of tangent to the circle, x square plus y square minus 4x plus 10y minus 8 is equal to 0. We have given a point, just put the points and verify. You can easily sort out what is our option in that case. Look at this one, they are overall positive, nothing will be cancelled. It is overall positive, nothing will be cancelled. If I put 3 here, 3, 6 1 6, 3 plus 6, 9, 9 minus 9, 0, it is our answer. On inspection for objective attempting or for entrance test. What about subjective? Let's see and find out. How to find tangent? Just replace x square by x times x1 and y square by y1 and x only, x plus x1 over 2 and y plus y1 over 2 to find the tangent direct. Okay, here is x square, we have x1 plus y1 minus 4, x plus x1 over 2 plus 10, y plus y1 over 2 minus 8 is equal to 0. Applying table, so this is our x1 unit point, that's of y1. Put here, it will become 3x only y. Applying table 2, x plus 3, applying table 5, y plus 1 minus 8 is going to be 0. 3x plus y minus 2x, 2 3, negative 6 plus 5y plus 5 minus 8 is equal to 0. 3x minus 2x, x, y plus 5y, both are positive, 6y, minus 6 plus 5 minus 1, so minus 9 is the answer in that case. That is our required tangent that we have already chosen. One can verify direct, put x3, y1, 6 times 1 minus 9. 9 minus 9, it is our answer, 0. 9 minus 9, it's our 0. That's the way to find tangent of any curve, tangent of anything. Replace x square by x1, y square by y1, and x by x plus x1 over 2, and y by y plus y1 over 2. I think we have arrived at final question, that is, if ax square plus 2hxy plus by square is equal to 0, then if the lines are perpendicular, then for the lines to be perpendicular, the lines to be perpendicular. What is the condition? What we have given? Second degree homogeneous equation, ax square plus 2hxy plus by square is equal to 0. This equation is known as second degree homogeneous equation passing through straight line, passing through origin, sorry. Second degree homogeneous equation passing through origin because it contains no constant term. Here this A is coefficient of x square, 2h is coefficient of x and y, b is coefficient of y square. There is no constant term, there is no constant, all terms are variable, all terms are variable. Now we have to prove that what is the condition for lines to be perpendicular. What is the condition for lines to be perpendicular? Let's split the equation. Let's find the two straight lines that are hidden in that equation, that has been concealed in that equation. Taking quadratic or making quadratic in terms of y, making quadratic in terms of y, it gives us advantage. We are in a position to direct find slope. Let's see how. That's it's quadratic according to y. It's quadratic according to y. Applying quadratic formula. So a is equal to b according to y. B is equal to 2hx. C is equal to ax square minus b plus minus times b square minus 4ac over 2a. Okay, minus b is 2 times hx plus minus root 2hx square minus 4 times b times ax square over 2 times b. So we have minus negative 2hx plus minus square of 2, 4 h square x square minus 4ab times x square over 2b over 2b. Taking 4x square common from the square root, y is equal to minus 2 hx plus minus 4x square common. What we have? H square from here, ab from here, left 2b. 4x square is the perfect square quantity. 4x square is the perfect square quantity. Root of 4x square is only 2x minus 2hx plus minus 2x times root h square minus ab over 2b. Taking 2x common, taking 2x common, we have minus h plus minus h square minus ab over 2b, 2 cancelled out. Y is equal to x times minus h plus minus h square minus ab over b. Look at this. Now we are in a position that these are our required slopes. Slope of first line is minus h plus h square minus ab over b, and the slope of other line is minus h square minus ab over b. Look at that. We have chosen quadratic according to y. Quadratic according to y. It gives us edge that direct we are in a position after splitting solving quadratic equation. That is our slope m1 and m2. Might you can name it m2. This is m1. Now we have to find the condition when the lines are perpendicular. When the lines are perpendicular. Let me check the frame what space I have still. Good. I can write here. For perpendicular, when two lines are perpendicular, the product of their slopes is equal to -1, or one can write slope of one is negative reciprocal of other. Slope of one line is negative reciprocal of other, or the product of their gradient slopes is equal to -1. Product of their slopes is equal to -1. Let me erase this. Putting values, minus h plus h square minus ab over b times minus h minus h square minus ab over b is equal to -1. B into b square shift on the right hand side. Look at this. This is our difference of two square situation. A plus b, a minus b. That is the only difference. Positive, negative. A plus b, a minus b. A plus b, a minus b. It is equal to a square minus b square h square minus ab is equal to -1 times b into b. It will turn to be positive h square, a square minus b square, root and root cancel. We have h square minus ab is equal to minus b square, or h square minus h square, negative times positive, negative b square. Cancelled out, we have ab minus b square, or dividing by b, we have a is equal to minus b, or a plus b is equal to 0. A plus b is equal to 0. When the two lines are perpendicular, the required condition is a plus b is equal to 0. A plus b is equal to 0. So option number B, sorry, A is correct in that case. It's my tiny effort to give you good view. What are the concepts behind the mathematics? How to solve MCQs or subjective, objective? This make no difference. You must have clarity. Your first step must be rationally driven rather than a blind arrow in there. It's all by itself. Next.